right at the, I said 2 or 3 things during when I was taking attendance, and I knew I took attendance because one thing is when I got to the Robinsons, I said I know everybody except Mahogany, and I knew I took attendance, but evidently either I hit the submit button and it didn't submit, or I didn't hit the submit button and it didn't submit. So of course that sends a message to student records that says that nobody was here on that day. That Left Behind plane just vanished, and everybody in the class was just vaporized. Okay, that's what it sends them. Then they send y'all an email that says that you were vaporized and that you did not exist that day. And then you email me saying that you did not exist that day. Okay, I'm not trying to overemphasize. I'm just trying to tell you that if you were here and I took attendance, then there must be some kind of what? Error somewhere. Okay? No need to get all hammy. Alright? I only got 15 out of 30 emails. 15. Of course, I did not respond to them because there's no use in doing it because I was going to address it this morning. I will take roll twice after class, okay? One will be from the other day, which I know all the Robinsons are here. But the rest of y'all I will take today also. So I apologize for that. So let's get started. Turn to page 6 or 5, and we will start talking about what definitions are important, what is important in the book in chapters 1 and 2. You should have already read chapters 1 and 2. You should already be done with chapters 1 and 2. Homework, you should be working on it. It's not that big of a deal. But we will talk about what's important and what's not. Now, you can go about doing this 2 different ways. You can go about and highlight what's in your book, or you can write it on index cards, or you can write it in notes, or you can just sit and listen. I don't care. Okay? But I would suggest that you do make some kind of mark beside the problems or beside the terms that I say are important, because therefore, when the test comes about, you'll know what's important, and you won't have to reread the whole chapter. All right. What are we doing in statistics? Well, when we are talking about statistics, let me just go ahead and give you a little synopsis of what we're doing. Okay. We are trying to predict the future, basically. Okay? Now, of course, we cannot predict the future, and we'll get to that when we talk about probability. And that's what probability is. Okay? In order to get to that point, we have to have some kind of math, or we have to have some kind of pattern, or we have to have some kind of evidence in order to get to this point. It's kind of like, I give this scenario every time we talk about probability. Have you ever gotten behind a little old lady on a very long highway, 2-lane highway, and they're going 35 miles an hour? I like to use the analogy of Wild Hog Road. Everybody in here knows where Wild Hog Road is. It's 187, goes up to Pendleton. It's out here past the double bridges. Garrett's, little store, turn right, and you go to Pendleton. It's a 2-lane road. It's about 6-8 miles long. Okay? If you're in 8 o'clock, if you've got to be at 8 o'clock class in Pendleton, it takes 16 minutes to get from 24 Bilo to Pendleton. 16 minutes if you drive moderately. Okay, so it's at 7:30, and you got to get penalty by the clock. And if you get on Wild Hog Road, you're going to get behind the little old lady, or you're going to get behind the school bus. All right? Now, school bus ain't that big of a deal. But the little old lady is, because the little old lady's going to go slower than the school bus. And you're going to get behind that little old lady. Guess which way she's going to turn when you get to the end of Pendleton? The end of Wild Hog Road. You can either turn left to go to Pendleton, or you can turn right to go to Sandy Springs. You're turning left. Which way do you think the little old lady's going to turn? How do you know that? Because of experience, because of you're in a hurry, because of Murphy's Law, and because you know that she's going to stay in front of you because you're in a hurry. All right? You're predicting the future. Even though there's a 50 shot, she's either going to Sandy Springs or you know she's going to turn left, and she does, because of your past experiences. So, what you do is you mentally record that, and then next time you get on another 2-lane road, and you in a hurry, and you are behind a little old lady, you're going to know that, okay, I'm going to turn on my right blinker, that way she'll turn right, and then I'm turning left. Okay? Anyway, you use those experiences and those things that you've done in the past to predict the future. Now, of course, you cannot predict the future as far as telling when somebody's going to die or anything like that. That's not. But you can use math to tell if somebody that does a lot of drinking and driving, you can ascertain that they ain't going to live very long. Why? Because one day, those cow horns will what? They will hook. And somebody that does a lot of drinking and driving, one day they're going to die. Or they're going to get somebody killed, one of the two. But that's because we're taking those statistics here and we're changing them into a prediction. All right? So, in order to be able to do probability, you've got to be able to do statistics. And statistics is what this is up here. This is statistics. Okay. Oh, that was writing. Was I not writing? I thought I was. This thing is not what it needs to be. Statistics is basically the gathering, calculating, and evaluating numbers. Now, of course, we're going to turn to the definition in the book now. No sneezing in class. All right. Statistics is the science of planning, studies, and experience, obtaining data, and organizing, summarizing, presenting, analyzing, and interpreting those data, and then drawing conclusion upon that data. Okay? Gathering, evaluating, and interpreting. All right? That's what statistics is. Data, that's what you collect. Population. Population is the big set that you're evaluating, and the sample is the smaller set. If Tri-County Tech students are a population, then Anderson campus would be a sample. If Anderson campus is the population, then this classroom, this class right here would be a sample. The sample is always the smaller set. I'm not going to worry about census. Census is not that important. That census is something that we take all the time every 10 years? But I'm not going to worry about that because that's not detrimental to you understanding what statistics is. Okay? So there's your first set of definitions that's important. 4 definitions out of 5. Data, statistics, population, and sample. So you need to mark those 4. Y'all sickly bunch. Drink more dang old juice. And yes, we're going to move around because I'm not going to make you memorize the whole book. I'm going to pick out the parts that's important so we can move on to the math. All right, make a note about page 11. Make sure that you review fractions, decimals, and percent. Make sure you can switch from a fraction to a decimal. Make sure you can switch from a decimal to a fraction, or a decimal to a percent, or a fraction to a percent. Make sure you can, do that. Make a note of that. That's on the top of page 11. There is a fan that has got a bad bearing in it or something that sounds like a cricket. Y'all hear it? It's driving me bananas. But anyway, I think we ought to call off class today because of it. What do y'all think?
Yes.
Yeah, I figured y'all was great. Bunch of losers. All y'all want to do is quit. All right, we're on 1.3, types of data. See, I told you this would go quick. All right, two very important terms, parameter and statistic. Parameter goes with population. Parameter, population, both start with P. And statistic goes with sample. Now, you would think that this is something that is real detrimental because they got it in an orange box or a yellow box or whatever color, manila or whatever color you say that is, khaki. But it's not that big of a deal. Let me show you let me fix that calibration first. I'm going to show you what what parameter and statistic is, and then you'll understand it a little bit better.
Always on my nerves.
All right. In probability and statistics, there's two sets. There is the sample and there is the population. Now, one thing about the population that most of the time rings true is that the population is usually too big for us to worry about. It's usually too big and too costly to, do the statistics on or the probability studies or whatever the case may be. So, what do we rely on to predict for the population? We rely on the sample. We rely on the sample to predict for the population because it's too big and too costly for us to do that. Now, for students to understand which one that we're dealing with, when we're talking about formulas, we're going to have formulas for the mean, and we're going to have formulas for the standard deviation. Over here, the same thing. Okay, they're the same formulas. Just about the same formulas. Except, when you're dealing with a sample, you're going to be using what? Statistics. Now, this is not the same word as the statistics that we had a while ago. The statistics we had a while ago was the gathering of data. All right, it's kind of a big word. And then this is a small word that says that if you are dealing with a sample, your mean is going to be X bar, and your standard deviation is going to be S. These two guys right here are the statistics. In other words, I hate it. I have to spend this time because it's two words that mean the same thing, or different meanings. Same word, different meanings. The first word, statistics, means that the gathering of data. The second word, statistic, means that you're dealing with X bar and S, which means that if you see these two variables on a test, on a report, on anything, you know that you're dealing with what? The sample. That's all it means. It's an indicator. So if you're sitting in a meeting, and whether you're a department head or a division chair or a whatever, floor manager, and you're going through a presentation, or you're reading through a presentation, and you see that X bar or S, you know that it's dealing with the population. That's what that means. Sample. If you see these two guys, mu, which I usually draw bass backwards, and omega, or not omega, sigma, if you see those two things, then what are you dealing with? You're dealing with the population, and these are parameters. So, what's important about these two words? They're indicators. Like I said, the best way for you to understand what these two things mean is if you're sitting in a meeting in your career, 5 or 6 years down the road here, and you're reading and you're reading and you're reading, or the person's presenting and you're reading along with the presentation on a PowerPoint or whatever, and you see X bar or you see S, and the S is usually going to be italicized. Then you automatically know, okay, well this is dealing with the sample. And if you read along the presentation and you see these two guys, you automatically know that we're dealing with what? Population. Capiche? That's all it means. Nothing big. Just you see those two, it means sample. You see these two, it means population. The formulas are the same. Okay. Now, if you go back to is a numerical measurement describing some characteristic of a population. Is a numerical measurement describing some characteristic of a sample. That definition means that hopefully you won't be ignorant in a meeting and mismatch the two and not know. That's what it means. Know the difference. Okay? This is a test question right here. This is a test question based on knowledge will be the test. Qualitative and quantitative. And if you've had probability and statistics before, you know the difference between the two. Qualitative consists of numbers. Quantitative. Have you ever heard of the saying, quality, not what? What's that mean?
How good something is versus how much there is of something.
Exactly. Quality, not quantity. You see this a lot in production. Think about a candy making business. How does a candy making business start off? Usually starts off with mom and dad or family or somebody. You ever seen a commercial where the woman puts together her toffee business from her mother's recipe? All right, it's a legalzoom.com or one of those. But she's saying, I started this business off with my mother's toffee recipe. Mostly, all of your big productions start off what? Start off small. And when they started off small, they put out a good product, but they didn't what? They didn't put out a lot, did they? and then they go through a transition, and then they become this big company, and they put out a lot, but they don't generally put out what? As good as product as when it was Mama's recipe. Think about it in your hamburger joints. Think about it, think about the first McDonald's. Do you think the first McDonald's tasted like what we have right down here on Whitehall? No. Probably tasted like a Hardee's. I'm sorry, I shouldn't have said that. One of the big Hardee's burgers, it was real good. It tasted like your backyard burger, but then it got kind of what? It got famous, and it got making money, and then the quality diminished, but the quantity what? Increased. We went over 3 test questions, so
I'm sorry.
failed. Quality and quantity. Make sure you know the difference between the two. Quantity. Now she's just making all kind of noises. Quantity. That means numbers. And qualitative means blonde, brunette, redhead, brown hair. Brown eyes, blue eyes, green eyes. Blue jeans or khakis. If you're taking a survey in the classroom, how many people are above 200 pounds? Well, that's quantitative. How many people have brown eyes? That's qualitative. Okay, see the difference between the two? All right, that's what you need to know. Make sure you know an example. They give you some examples in the reading, so make sure you read them. I think they give you a couple of examples. So that's all I need you to do is make sure you know the difference between the two. Now, this one I spend a little bit of extra time on because a lot of people don't know the difference between discrete and continuous. If I was to ask you right now, if I was to send out a piece of paper or tell you to get out a piece of paper right now and tell you what is the meaning of discrete data and what is the meaning of continuous data, and you write down your definitions, half of you wouldn't even write down anything because you have no idea. And half of you would take a swag. What's swag? Simple, wild attitude, yes. Swag, simple, wild, yes. And some of you would actually probably know it from a class that you've had in the past, and you've actually remembered something out of that class. All right? So discrete and continuous. Well, first of all, I'm going to start with rational and irrational. Another word that if I asked you to write a definition of, half of you would not be able to. Half of you would guess, and then the rest, a quarter of the class, maybe a quarter or less, would actually get it halfway right. What is rational? Anybody give me a layman's term definition? No, it doesn't have to be mathematical, just a number that is what? And irrational would be a number that is not. Predictable. Predictable. I can't spell. Predictable. What in the world is he talking about? What is predictable? Well, let's do a couple. Why are all these predictable? These are all rational numbers. Why? Rational because they got a ratio. They're a fraction. No, 1.33 is not. 5's not. 5's a decimal, or 1.33 is a decimal, and 5 is a whole number. So you can't say rational are all fractions. That's not right. Why are they predictable? Because 1/2 will always give you what? If you divide 1/2, that will always give you what? 0.5. It will never change. You can bet your money on it. You can bet a $100 bill that whatever you punch into a calculator, if it's got the ratio of 1 to 2, your answer is going to be what? 0.5. Is there any doubt? No. What about 3/4? What's it always going to be? 0.75. No doubt. 5 over 1 is what? 5. There's no doubt. 4 over 2 is what? 2. There's no doubt. Why is this predictable? Because you know that next number is what? 3. Next number is 3. You know that without a shadow of a doubt. What's this? Well, numbers that are not predictable. Square root of 7. Get your calculators out. Square root of 2. I'll just pick out 3 numbers that are irrational. Okay, now somebody's got a calculator. Take the square root of 7 and give me that number. You're going to give me about 10 digits because your calculator only goes to 10 digits. Just go slow. Don't be saying 1.56333. I can't write that fast. All right, you got to go slow. What? 2.645713111. That it? Okay, somebody tell me what that next number is. Anybody? Anybody want to put a $100 bill on it? You never know. You don't know. You don't know unless you actually calculate it. There's no prediction. There is no guarantee that this next number is a 5. There is no guarantee that this next number is a 3. Where up here, you know the next number, you know that this number, there is a location point. There is a distinct end to your number. Square root of 2. Somebody give me that number. 1.41. I'm sorry, 41? 42. 13. 56. 2. Somebody want to take a stab at that next number? You can't, because you don't know. And somebody give me pi. 3.141593. What is it? 3.14 9265. Anything else? Huh? 4. And somebody can maybe predict that next number. You can't. What in the world does this have to do with discrete and continuous? Same thing. If I was to give y'all, of course y'all can't see out the window here, but there is a fire hydrant right down there. It's a red fire hydrant. Just believe me, okay? There's a fire hydrant down there. And I bring in a box, a cardboard box of measuring utensils, measuring tools. What could they be? Well, be a yardstick, could be a tape measure, it could be a carpenter's tape measure, it could be a digital tape measure, all different kinds. Maybe 5 or 6 different kinds. And I'd give y'all each a different type. Some of you may have the same type of tape measure. Some of you may have digital tape measure. Some of you may know what the carpenter's tape measure looks like, the folding carpenter's tape measure. Some of you may have that. Some of you may have just a cloth tape measure. Some of you may have a 100-foot tape. Some of you may have a yardstick. And I send every one of you down to that at different times of the class. And you go down there, and I tell you to measure the height of that, what's it called? Fire hydrant. Okay? I tell you to measure the height of that fire hydrant. How many different, would we all get the same height? No, because half of you couldn't read tape measure. No, that's just not picking on y'all. That's just statistics. Half people that graduate high school cannot read tape measure. And we all know it's Bush's fault. It's not the school's fault, is it? It's not the student's fault. It's Bush's fault. Okay? Half students that come out of high school, half of y'all would guess and say, okay, that's 3 foot and there's 4 marks, 3.4. That's what y'all would put. And then half of you would read it somewhat correctly. But half of you would read different marks on the measure, and some of y'all would kick out around the mulch and measure where the metal actually hit the pipe, the water pipe that it's sitting on. So, what can you tell me? How many different measurements would I get? Well, there's 30 people in here. How many different measurements would I get? Probably 20. So, that would be continuous. Something that is, what is height? It's something that is what? Measured. Anything that is measured is going to be continuous. Why? Somebody tell me why. I just told you why. Because different readings. I can give y'all all the same tape measure. I can give y'all the same tape measure that reads digitally, and y'all would still give me different answers because of the way you're reading it. Versus what? Well, first of all, it's measured. What are measured? What things are measured? I just told you one, height. Oops. What else? Weight. What else? Huh? Width. Well, all that good stuff. Anything that's measured. Anything. Height, weight. I always forget about one other one. There's another one. Just think of it. Okay? But, what's the opposite of measured? Well, what if I told you, what if I locked the gate of the entrance there and the entrance up out here, locked them, closed those gates, and I told y'all to go out and count the number of white cars, white vehicles in the parking lot. How many of you would come up with different? Less. Well, some of y'all can't count. But, most of y'all could count, and most of y'all would come in with the same number. Why? Because y'all would check 3 or 4 times to make sure that you counted all the white cars in the parking lot, and eventually y'all would come up with the same what? Counts. So when you're talking about rational, are you talking about discrete? You're talking